Let's see this case. The string between the blocks of mass m and 2m is massless and inextensible. The system is suspended by a massless spring as shown in the figure. If the string is cut down, find the acceleration of m and 2m after cutting the string, immediately after cutting. I'll explain this problem. Let's take the situation and let's analyze it first before cutting the spring. If you see the situation before cutting the spring, you'll see that the spring is extended, where an extended spring pulls up with kx. And then there is a string at the below which would pull both its ends with t and t. Along with that, gravity would act on the first block as well as gravity would act on the second block. See the FBD of the first block, we'll have kx is equal to 2mg plus t. And see the second block, t must be equal to mg. So kx is t plus 2mg and t is mg. So kx comes out to be 2mg plus mg, or kx comes out to be 3mg. This is the spring force. Now one benefit of spring is, let's say if we take after cutting the string, see blocks cannot move instantaneously. So if before cutting a spring its length was L0 plus x, then immediately after also length would be the same. So spring force still would be equal to kx or equal to 3mg. That means just after cutting a string, spring force remains constant. Now let's use it to our benefit, as in let's have a roof, a spring constant k, one block of mass 2m, and if we cut down the string there would be just another block of mass m, so that on the lower block mg would act downward, which causes an acceleration a. So for the lower block, force would be mass into acceleration, or mg must be equal to mass into acceleration, or for the lower block acceleration would come out to be g. Similarly, see it for the upper block, kx acts upward, 2mg acts downward, so that it goes up with an acceleration a. For it, net force would be mass into acceleration. Kx minus 2mg is mass 2m, acceleration a. 3mg minus 2mg is 2ma. Calculate a from here, a would come out to be g by 2. So the upper block rises up with an acceleration of g by 2, while the lower block goes down with an acceleration equal to g, given by option number C. That's the answer.